On August 15, 1977, a volunteer astronomer named Jerry Ehman was reviewing a printout of radio telescope data collected 3 days earlier. He was scanning columns of numbers, looking for anything unusual in the recordings from a telescope in Ohio that had been listening to the sky for signals that did not fit the background noise of the cosmos. He found something. A column of intensity values so far above everything around it that the numbers climbed off the scale the printout used to measure them. He circled it in red pen and wrote one word in the margin. Wow. That single annotation became the name of the most significant unidentified radio signal ever received from space. It has never been detected again. It has never been fully explained. And in September of 2025, nearly half a century later, scientists announced that new analysis of the original data had produced the clearest picture yet of what it was and where it came from. And the result of that analysis did not solve the mystery. It deepened it. Stay with me, because the story of what reaches Earth from the depths of space is not a collection of curiosities. It is a record of things that should not exist, arriving without warning, and in some cases leaving without explanation. The WOW signal was not just unusual. It was, in the technical language of radio astronomy, almost exactly what scientists had predicted an alien transmission would look like. The frequency it arrived on, 1420 MHz, is the emission frequency of neutral hydrogen, the most abundant element in the universe. Scientists had long reasoned that any intelligent civilization capable of building radio technology would know this frequency, would recognize it as a cosmic landmark that any other technological species would also monitor, and might logically choose to broadcast near it as a universal calling signal. The WOW signal arrived precisely in this range. It lasted exactly 72 seconds, which corresponds to the time it takes the Earth's rotation to carry a fixed point in the sky through the telescope's field of view, meaning it appeared and disappeared exactly as a real, stationary, cosmic source would. It was narrowband, occupying a very specific slice of the radio spectrum, rather than spread across many frequencies the way most natural phenomena are, and it was 30 times stronger than the surrounding background noise of deep space. Every one of these characteristics matched what scientists expected a genuine alien transmission to look like. It was never detected again, despite multiple searches by multiple telescopes over the following decades, including dedicated follow-up observations by the same telescope that originally found it. The signal has never returned. This absence cuts in two directions. It makes the alien explanation more difficult to sustain, because a civilization sending a beacon would presumably send it repeatedly, not once. But it also makes every natural explanation harder, because the natural phenomena that can produce a brief, intense, narrowband signal at hydrogen frequency without repeating are extremely specific, and in this case have never been identified. The September 2025 study, led by researchers at the Planetary Habitability Laboratory in Puerto Rico, and involving volunteers who processed 75,000 pages of original signal data through optical character recognition software, was able to narrow down the specific region of sky the signal came from with significantly greater precision than previous analysis. Their work also produced a revised estimate of the signal's strength, suggesting it was considerably more powerful than previously calculated. Their conclusion was careful and honest. Their results did not solve the mystery of the WOW signal. They gave us the clearest picture yet of what it was and where it came from. But what it was remains an open question. The most widely discussed natural explanation is that the signal was produced by a brief brightening of hydrogen gas stimulated by a powerful transient event, possibly a magnetar flare, or a burst from a type of neutron star called a soft gamma repeater. A magnetar is a neutron star with a magnetic field so intense that it dwarfs anything else in the known universe, capable of releasing more energy in a fraction of a second than our sun produces in 100,000 years. If such an event struck a cloud of interstellar hydrogen at the right density and geometry, the interaction could theoretically produce exactly the kind of brief, narrowband hydrogen frequency burst that the WOW signal represents. This is a plausible mechanism. It is not a proven one. No magnetar or soft gamma repeater has ever been confirmed to have produced an event in the direction of the WOW signal on the date it was recorded. The explanation remains a hypothesis, not a resolution, and the signal remains, officially and accurately, unexplained. While astronomers were still debating the WOW signal, the cosmos sensed something new. In 2020, the Breakthrough Listen project, one of the most sensitive and best-funded SETI efforts in history, detected something that came closer to a confirmed alien signal than anything in the intervening 43 years since the WOW. It was designated BLC-1. It appeared to originate from Proxima Centauri, the closest star to our Sun, a red dwarf orbiting just over 4 light-years away and known to host at least one rocky planet in or near its habitable zone. The signal was narrowband, arriving at 982 MHz. It showed a slight frequency drift consistent with the Doppler effect you would expect from a source on a planet in motion around its star. When it appeared and disappeared, it did so in correlation with where the telescope was pointing, appearing when the telescope was aimed at Proxima Centauri and vanishing when the telescope moved away. It passed every initial test for a signal of artificial, non-terrestrial origin. The excitement lasted nearly 2 years, and then, in 2021, researchers published their conclusion: BLC-1 was almost certainly human-made radio interference, not an alien transmission, a signal from Earth's own technology somehow reaching the telescope and masquerading as a cosmic source. The specific mechanism by which terrestrial interference could have mimicked the Doppler drift and the narrow bandwidth of BLC-1, while appearing to correlate with the telescope's pointing direction, is still not fully characterized. But the balance of evidence pointed decisively toward a mundane origin. The alien hypothesis was set aside. The signal was closed. But what BLC-1 actually demonstrated, and what most coverage of its resolution missed, was something important about the current state of the search. The instruments are now sensitive enough to detect signals that look convincingly like what we expect alien transmissions to look like. The problem is that our own technological civilization produces enough radio noise that some of it inevitably reaches our telescopes and fools our initial analysis. We are, in a very literal sense, getting in our own way. And then there are the signals that require no speculation about alien origins, because what they reveal about the natural universe is already more extreme than most people can easily process. Fast radio bursts, first discovered in 2007, are millisecond duration pulses of radio energy so intense that in the fraction of a second they exist. A single burst releases more energy than the sun produces in decades. They arrive from outside our galaxy, from distances of billions of light years. They were initially dismissed as instrument errors, then as natural phenomena that would quickly be explained, and then as one of the most significant unsolved problems in astrophysics, because despite more than a decade of increasingly sophisticated observation, they have resisted a single clean explanation. Some are one-time events, appearing once and never repeating. Some are repeaters, firing multiple bursts from the same location over time. And in 2024 and 2025, a source designated FRB 202-40619d was discovered using the Meerkat telescope in South Africa, firing 249 detectable bursts in a single observation session, making it one of the most hyperactive repeating sources ever recorded. The repeating behavior has been crucial because it rules out the most obvious explanations. A catastrophic one-time event like a stellar explosion cannot produce a source that fires hundreds of bursts over months of observation. The leading current hypothesis links repeating FRBs to magnetars, specifically to magnetars in unusual environments, possibly in binary systems where interaction with a companion object drives periodic activity. In 2025, researchers at MIT produced the first clear direct evidence linking one specific FRB to an extremely compact, magnetically active object by analyzing how the signal appeared to twinkle as it passed through intervening material in space. The same optical effect that makes stars appear to twinkle in Earth's atmosphere. But even this result addressed only some FRBs and left the broader phenomenon partially unexplained. The most distant fast radio burst detected to date, designated FRB 202-40304b and published in Research from 2025, originated at a time when the universe was only 3 billion years old, meaning it traveled more than 10 billion light-years before reaching our instruments. The information encoded in how this signal was scattered and distorted by the plasma it passed through across 10 billion light-years contains direct observational data about what the universe looked like in conditions that no other form of observation can reach. And in 2026, astronomers detected a gamma-ray burst so powerful and so ancient that it stands in a category of its own. Gamma-ray bursts are already the most energetic explosions in the observable universe, releasing in seconds more energy than the sun will emit across its entire 10 billion-year lifetime. The one detected in 2026 originated approximately 13 billion light-years away, meaning the explosion that produced it occurred when the universe was less than a billion years old, in the era of the first generation of massive stars. What made it particularly significant was precisely this timing. Stars in the early universe formed under conditions radically different from those that govern star formation today. There were almost no heavy elements. The first stars were massive, strange, and short-lived in ways that models of modern stellar physics do not fully capture. This gamma-ray burst is direct observational evidence of what those early stars did when they died. A signal from cosmic prehistory, carrying information about a universe that no longer exists in the form it had when the signal began its journey. What connects all of these signals is not a common explanation. They are almost certainly different phenomena with different origins. What connects them is what they reveal about the universe we are actually listening to. It is a universe where single events routinely release energy that dwarfs anything in human experience, where signals from distances so vast that the light travel time exceeds the age of our planet arrive carrying information about conditions that predated Earth's existence, where the most sensitive instruments we have built are now capable of detecting phenomena so faint that our own civilization's radio noise drowns them out, and where the most famous unexplained signal in the history of radio astronomy, received on a single night in 1977, has withstood nearly 50 years of scientific scrutiny without producing a definitive natural explanation. The universe is not quiet. It is extraordinarily loud. The question that all of this leaves genuinely open is not whether signals are reaching us. They are, constantly, from every direction, across every frequency we can monitor. The question is whether any of what we are receiving is someone trying to be heard, and the honest answer, in 2026, is the same as it was in 1977. We do not know. What we know is that we are listening more carefully than ever before, and that some of what we are hearing does not yet have a name.